All right, we're recording. We're here. First off, thank you. I'm going to give a more official intro later, but feel free to make yourselves comfortable. Johannes, take it away.
All right. Well, thank you so much for having me. I'm not going to waste a lot of time, but jump right into my presentation. Just give me 1 second to share my screen. So I'll do this, and there we go. All right. So my name is Johannes Fahrenkrug. I'm a freelance iOS and Mac developer, and I have done that for longer than I care to admit, since 2007. And today I want to just talk a little bit about virtualization framework. And we'll just scratch the surface because that's how deep my knowledge of it goes. But I think it's very interesting and can be very helpful, especially to try out beta releases of new OS versions. So we'll cover just a few things. What is virtualization framework? How can you use it? And a very quick demo, because we only have 5 minutes. So my interest was piqued in this year's session, Create macOS or Linux Virtual Machines of WWDC 2022. And if you have a chance, go ahead and watch that session. It's only 23 minutes and worth your time. So virtualization framework has been around since macOS 11, and it's built on top of hypervisor framework. And hypervisor is a much more low-level framework that lets you create virtual CPUs, virtual memory, and so on. Virtualization framework was built on top of it to make it much more convenient and easy to run full operating systems without having to worry about all of the nitty-gritty, very low-level details. And so how do you use it? Well, you can compare it to configuring a Mac in the Apple online store. So when you want to use virtualization framework, you start with the configuration. And instead of clicking it like here or in a piece of commercial software like Parallels or VMware, you configure your virtual machine in Swift code. What does that look like? Well, you start with a VZ virtual machine configuration. And on that configuration, you configure everything that needs to be set for your virtual machine that you want to create. For example, the platform, either Linux or macOS. And there's a little note, macOS virtualization only works on Apple Silicon. Linux virtualization works both on Intel and Apple Silicon. You set things like the CPU count, the memory size, and then things like the bootloader, graphics device, storage, network, pointer, keyboard, audio, and so on. And once you have all of that configured, you create a VZ virtual machine with that configuration. And you can think of that like the MacBook that arrives in the mail after you've ordered your configuration in the Apple Store. And then what do you do with that virtual machine? Well, you create a VZ virtual machine view. And if you've ever done any Mac development, macOS development, this is can be treated just like an NS view, which is the equivalent of a UI view. Then on that virtual machine view, you have a virtual machine property, and you assign the virtual machine that you just created to that property. And then you start the machine. How can you run this on your own device? Well, if you search for virtualization framework, the second hit is a sample code project from Apple called Running macOS in a Virtual Machine on Apple Silicon Macs. And you can download that and then run it straight on your machine. And it comes with 2 parts. One tool that actually downloads and installs a macOS, and then the other part that actually runs it and displays it in a window. So it's very convenient. And inside of that virtual machine, you can then update it to a beta release or whatever else you want to do. Or you can right away install a beta release. There is a more convenient way too. On GitHub, there's a project called VirtualBuddy, and it kind of walks you through the steps of installing a virtual machine. So after you start it, you're presented with this view, and then you can select how you want to install. So if you select download macOS installer, you get a list of options, even the latest beta, and then it goes ahead and downloads it for you. So I started this shortly before the presentation, so this didn't finish, but I have a different demo for you that I can show just briefly. I'll stop my share, and I'll share the window of the virtual machine sample app from Apple. So here it is, and I can log in, and I can see here, it's a virtual machine. It says M1 Max virtual, and it's running Ventura inside of here. And you can even run Xcode inside of it too, anything else you can imagine. So you have a full-fledged operating system. And I haven't updated my main machine to Ventura yet, but with this sample app, it's super easy to try out Ventura without sacrificing any hardware to it. And that's it. Thank you for your attention.
Hey everyone. Let me share my slides real quickly. Here we go. Maybe we can see it. Yeah, cool. So I'm gonna do my best to kind of blaze through all the top new things that came out in Swift 5.7 as quickly as possible. Just give you an overview of new things you should look out for. My name is Shai. If you don't know me, I'm a tech lead for money.com. I'm doing iOS for about 10 years at this point, and a lot of open source work that some of you might be familiar with. So first thing that some of you might already be familiar with is the new shorthand optional unwrapping syntax. So instead of having to do this long if let something equals something, we can finally drop the right part and simply go with if let optional value and already get an unwrapped option inside the scope of the if. And we can do the same with a while let loop as well as a guard. Super useful, cleans up a lot of longer code. Regex, there's an entire session about this today, so I won't go too deep into it. But as you see, I have a very simple string-based regex that takes the hex color from a string. It will fail silently if there's a typo in the pattern. We have to kind of use manual ranges everywhere. And it's very messy and explicit to extract data from resulting matches. So now we have a super powered regex machine inside Swift itself, powered by the compiler. So this isn't a string anymore. It is an actual Swift expression validated by the compiler. If we have a typo inside our regex, the compiler will let us know there is an issue and that's not a valid regex anymore, which is super nice. We actually get a strictly typed tuple of the matches. So here I have 3 grouped matches, so I can actually go to .0, .1, .3, 2.3 and get the right match. You can even have named matches, and I have no idea what kind of voodoo Apple is doing to make this happen, but the tuple actually has the named labels inside. So if you call it first hex, second hex, third hex, you would actually get that inside the tuple, which is pretty amazing. For people who don't feel comfortable with the cryptic regex syntax, there is a result builder option, which is really nice. You can kind of dig deeper into it if you wish to do so. About using async await in top level code, if you ever written a CLI that use async await, you know you would have to write this hack with an @main with a struct. This isn't needed anymore. You can just write your async await based code at the top level of your main Swift file and it just works with no issues. We have a new SPM plugins, which are super nice and way overdue. We have command plugins where you can run commands that are associated with the Swift package and require active user interaction to confirm running, and they're great for one-off tasks. And we have actual build tool plugins that are kind of like run phase scripts for SPM. They're part of the build process, great for linting, source code formatting, stuff like that. A few generic changes that are really, really nice. We can now define concrete default values for generic expressions. For example, here I have this elements, which is a generic T collection. And I can say that by default, if I don't pass anything to pick element, the default will be a range of 1 through 100, and T is inferred as a collection of integers. But I can also pass explicitly a collection of any other type, and it just works. It's not super clear to me the use cases for this, but I'm sure there are some. And a few more generic additions. Until now, we could use opaque types only for return types. Now we can use it in other places that just make sense. For example, instead of having to generalize V as a vehicle, we can just say that we want to accept some vehicle. And that is basically a parallel that is much nicer looking and much more readable and understandable. There's also a new any keyword. So if we look at some always refers to some specific concrete types. So we could pass 3 cars, but we can't pass 3 different vehicles. If you want to pass 3 different vehicles, we could accept an array of any vehicle, and then this code works. That's the difference between some and any. Also, we have the any keyword is basically kind of a compiler-backed version for type eraser. It is a bit slimmer from the possibilities that it offers, but it does replace a lot of these manual types that we had until today to type erase protocol-based stuff. This also kind of gets rid of this weird message that some of you know and hate, where if you want to pass an array of a protocol that has an associated type, you would get this has self or associated type requirements. We can just pass an array of any request type, and then that just works as you expect it to. Another really nice change here, for example, I have this fill fuel method that's generic over a V vehicle where V kind is a gasoline. So I can only pump fuel for a gasoline vehicle. Now I can do this weird new trick called a primary associated type, where I can say for the protocol, it has this new primary associated type, which is the kind. And then I can say that I allow to fill fuel only for some vehicle of gasoline. It's a bit of a weird syntax to get used to, but it's actually really, really nice compared to how long this took before, like how long the syntax was before this. Distributed actors, huge topic, not gonna dive deep into it, but it does kind of let you isolate and protect immutable state like a regular actor, but across multiple processes, for example, network, layer, or even like different processes. You have a new available no async. You can put this on a method to say that it cannot be executed from an async function. There's a new result builder called build partial block, which is gonna result in a lot less duplication of these kind of methods where we have to specialize for a lot of generic variations. So instead of having a VStack with overload of 4, we can have these 2 new methods on result builders, where instead of having to match 4 arguments, we can just iteratively build text 2 on top of 1, text 3 on top of 2, etc., etc. And that allows us to build very, very complex and long blocks without having overloads that fit all the way up to 10 or 20 or 50 variations. We have a lot of focus on Swift async algorithms this year, probably as a replacement to combine over the long term, and a lot of new tooling for concurrency debugging, such as the new concurrency tablet for instruments. Apple is really pushing hard for us to use SwiftUI for new apps, basically saying if you are making a new app, you should try SwiftUI first. That's it. That's all I have for you today. I hope you enjoyed this quick blazing overview of Swift 5.7.
So private access tokens, I think were my favorite thing announced at WWDC. I think it's kind of one of those underappreciated, very cool things that they put out. And I think part of the problem was that the naming is kind of confusing. Apple has what they call private access tokens, and it's an implementation of a general IETF standard called the Privacy Pass Framework. Google has a version of it they're calling trust tokens. Privacy Pass is also a plugin that implements this Privacy Pass framework, but they're all kind of the same thing, except that Apple's adds some stuff for free that makes it pretty nice. I kind of like Google's explanation of the general framework. They say trust tokens enable trust in a user's authenticity to be conveyed from one context to another to help sites combat fraud and distinguish bots from real humans without passive tracking. And the way that Apple really makes this usable out of the box is that in this case, Apple is the one verifying the authenticity. It's making sure that it's a real user. So what they check is that number one, it's a real device. Number two, that it's logged into an Apple ID account in good standing, though I think they're kind of hand wavy about what exactly that means. Basically, they say they think it's a real person. And then number three, that it's not hitting a rate limit. So, you can't set up a device and go through this process over and over and over again. Eventually, they're going to say like, hey, that doesn't look like a real person. That's something automated. So going back to what Google said, it kind of works out to private access tokens enable trust in a user's authenticity verified by Apple to be conveyed from Apple to you, an API without passive tracking. So it's basically a way for an API to know that whatever's calling that API is a real person using a real Apple device without having to use a CAPTCHA. So the CAPTCHAs are like the main thing they bring up as what they are trying to replace. And you trust Apple to be able to verify this stuff. So that's where this trust comes from. And here's kind of a visual breakdown of how it works. You have either an app or a web browser on iOS 16 shown as the client on the phone in the middle here. And server.example.com says, hey, I want to make sure that this is a real device. So it tells the client. The client then reaches out to the iCloud attester. And this is really the part that Apple adds that is nice. If you're wanting to use the general protocol, you have to have, like, it's almost like the attesting that it's real is left as an exercise to the reader. Like they just assume that you're going to be able to verify that somehow, and then you're going to be able to convey that to someone else. Well, Apple's taking care of that for us here, so that's what's exciting. So Apple does something to verify the device is real. It's probably based on their the iOS attestation that they added to Device Check a couple of years ago, some other secret things they do. Once the iCloud attester has decided, yes, this is a real person, it then contacts the issuer, who is a party that the server already said that they trust, and the issuer issues a digital signature that gets passed back to the attester, back to the client, and the client can present it to the server. And the server can check that signature and tell that it's real. Now, the reason this is all private is because the server never gets to see your iCloud account or your device details. All they know is that Apple has vouched for you. And at the same time, the issuer who's performing this digital signature doesn't know that the token is destined for the server. The server can offer a random challenge to prevent replay attacks, but that is blinded before the digital signature stuff happens. So the issuer never gets to see the exact version of that. So there's some pretty cool cryptography going on here to keep privacy protected. What's kind of weird, and then this is where I really started scratching my head. The way this is implemented is kind of cool, but also a little weird. So the app or the browser sends some kind of HTTP request to the server. The server responds with a HTTP 401 unauthorized with a special header saying that, hey, I want proof that you're real. And then in number 3 here, iOS or Mac OS, without telling your app or the browser, goes through the attestation and getting the token from the iCloud attester and from the issuer, without the app or the browser being involved in the process at all. And so once it has that token, it sends it back to the server as another HTTP request with that stuff added to an authorization header. And so from, if you're an app writer, from your perspective, the app has just made one request to the server. But the server sees one request, sees a response with a HTTP 401, and then sees that same request with a new header, and they can respond with a 200 or whatever. So it's completely transparent to the app, which is kind of cool, but also a little spooky. That means that every request that is to one of these protected APIs is going to have to be sent twice, because that API is going to have to give the 401, and you could jump through those hoops. So I have a note here that dashboards are going to hate it, because you're going to double the number of requests to APIs. It's going to look like your error rates have gone up, etc. So one of the suggestions I have here is, instead of adding this protection to your login or whatever, set up a dedicated API that only devices that are capable of answering this token challenge will hit. And so maybe they'll hit that API, they'll do the 401, they'll get the token, they'll send it back, and then that new API can give you a cookie or something like that then you send a login. And that way, all those 401s are at the new API rather than at your login. So I've got a couple of sample headers here showing what it looks like when the server sends back that 401. It has a challenge. This is just a random thing to prevent somebody from replaying the same response over and over again. As an aside, a client would have to be pretty heavily modified to do that, because not only does your app not know that this exchange is happening, but you don't get to see the token. So even if you wanted to reuse the same token, that the app doesn't get that chance. But the challenge is there, and then also the public key of the issuer that you want to use. And then, as I said, iOS goes through the token, the process to get a token, and sends back the token in an authorization header. So, as I said, this is a way to avoid CAPTCHAs or other similar technologies. It is transparent to the app and to the browser, which is kind of cool. But it can add a little bit of latency. iOS will cache tokens, and so if there are cache tokens on the device, it doesn't add any latency there. But you do have this weird kind of 401 200 dance. But it's a lot easier to use than the device check attestation, and it's more privacy protecting than some other technologies. You don't have to add an extra SDK to your app, but it is iOS 16 and up, or macOS Ventura and up only. And that's that.
Cool. Hello, everyone. My name is Ariel Steinloff. I'm an iOS engineer at OkCupid. There was a lot of really cool things announced at WWDC, but one of the things that really stood out to me was the new layout API. And I know the title of the talk says AnyLayout, which is the type eraser, but I'll get into that in a little bit. Yeah, so I have a few short slides, and then I have a short demo demonstrating the new API. So let's get right into it. Whoops. Talk about container views. So in SwiftUI, you usually lay out your UI using things like HStack and VStack and ZStack, but these are great. But sometimes you just need a little more. Flexibility and freedom. Not all views are aligned in such a way. So this is where the layout API comes about. What is layout? It's a type that defines a geometry of a collection of views. It's a protocol with in other words, it's a protocol with two required methods. This is what it looks like, the two required methods. And a few things stood out to me when I first saw this. First being, we have like a method that, returns a size, and we have proposed view sizes. And then you have another one that plays subviews. And to really understand this, I had to sort of go back and sort of understanding how view sizing works in SwiftUI. With this context, you'll find out that in SwiftUI, when a view is laying out a child, the parent says, hey, I have 1,000 pixels of space. How much do you need? The child view would say, oh, I only need like 500 or something. And then the parent will place it in its coordinate space. And so oh, by the way, that's a great talk. If you're curious about learning more about the SwiftUI layout process. And so looking back at the API, we see now that the layout protocol gives us access to this process, gives us you know, the first method is size that fits. And we have a proposal, which takes a proposed view size. And so what this is saying, the parent view is giving us a size, and then we have to say, how much do we need? And so we return a size. The next method is place subviews, and it gives us a bounds in which we place our views. And we also get access to a type here called subviews. And the important thing to note here is that you don't get direct access to the views. These are proxy object views. So you can do things to the views like ask for their size and things of that nature. And so I have a short little demo. So I'm going to just switch over to Xcode right now. Okay. So here I have a very simple little app. This is just a grid of all the pets of employees at OkCupid for some of them. And in it, it has a little toggle that you can switch between horizontal and vertical, which is great. And you could see in the code, I'm switching on a type that I defined here. And I'm using the AnyLayout that Shai mentioned. And you know, I'm returning an H-stack or V-stack depending on which layout we want. But I think it would be cool if we can have our views sort of arranged in a circle. And so with layout, it's actually pretty simple to do something like that. All we need to do is define a type that conforms to this new layout protocol. So over here, I have a file that I pre-prepared that you know, implements the layout protocol. So the first method here, size that fits. All I'm doing here is I'm taking the proposal and I'm saying, give me everything you have, and I'm going to take up all the space. They're replacing undefined dimensions. A proposed view size can have an optional width and height. So this will just fill it out for you and give me a concrete CG size. So this is basically saying just take up all the space. And then the next method I have here is place subviews. So let me click this. And all it's doing is I'm going for every subview, and I'm calculating a point somewhere in the bounds of the view. And then I'm just simply placing it at the view. And I have this function here that's calculate point. This is sort of tweaked Apple code, but I don't know why it's not expanding. But all it really does is it finds a point along a circle and places in the view's bounds. And the point is that you can change this to anything you want. You can put them anywhere in the view's bounds. It's crazy powerful. And so if we go back over to our content view, yeah, how do I turn this off? Draw. Apologies. Okay, we go back to our content view. I'm going to add a new layout called circle. Circle, and then I'm going to just return our new layout that we just defined. Return simple circle layout, and we run this. And now let's switch over to our new layout. Great, we have all our views in a circle, which is crazy how little code we had to do, but it gets even better. It's kind of jumpy whenever I switch between the layouts. It would be nice if we can have a smooth transition. Well, all I need to do is go over here and say, animate the layout. Wait a second, .ease in, and then we'll say our layout type, run this. And we go over here. And we get all that functionality for free. Crazy. So that's the demo. I'll just say that there's a lot more powerful things that this can do. For example, you saw that there was a cache in the method signature. You can use that to, if you're doing expensive calculations, you can actually have a cache to reuse your calculations, but you should only use that if you're running into performance hitches. You can also do things like set values on views if you want like a certain view somewhere else in the bounds. You can animate it any way you want. So you can probably run like a custom animation, set the timer. But yeah, that's my demo. Thank you very much.
Can you show that layout code now that the pointer is working?
What was that?
Show the layout code.
The layout code.
Expand it.
Yeah. Sorry, this thing's in the way. So this is sort of tweaked from Apple's sample code.
Yeah, it's around 80. Cool.
Thanks.
Cool. Thanks, Ariel.
Yep. Cool. All right, Swift UI chart. So this is my little agenda. Why I use charts, quick intro to Swift UI, making charts the old way with Swift UI. And so first off, why use charts? It helps people understand, visualize complex information. Helps us see the big picture, helps in comparing data. For example, Dow Jones, for example, this was yesterday, looks good, but if you saw the whole year, it's going terribly right now. Maybe if you have a banking app, you're going to want to see all these different comparisons. It's really helpful to know, to understand. Otherwise, you don't want to look at all that data. Or, you can use it for something else. Say if you have a sadistic video game that you're playing called Elden Ring, you might want to do it that way. Get it? Good. Okay, so intro to Swift UI. Raising of hands, how many people are familiar with Swift UI here? Okay, most people. Good, because I'm not going to do that. I don't have time. So we're just going to skip right ahead. Sorry. So I have an example graph here. So it plots weight over time. Why did I choose weight? It's not my personal weight. Let's just say, let's say it's not my personal weight. And maybe I had a certain fascination with this over the last 2 years for some reason. So I might have used, or a person I know might have used an app that charted weight. And I was just curious how easy that would be. So this is the data that I'm going to use for that, for this example. We just have an X value and a Y value, just a simple plot point. And in this case, it's going to be date, because time charting based on time is nice, especially for weight. The old way with Swift UI isn't actually too bad. You just have this geometry reader. This is all very simple with Swift UI. It tells you the screen size. It's very easy. And then you make a horizontal stack. And then for bar chart, you just make a bunch of rectangles, and boom, you got your little chart. Likewise, you could do a path and make a line chart. Looks something like that. Easy, right? I lied. It's not that easy at all. So especially if you start thinking about how complicated data can be. So here, I don't know if you guys can see this, but the date here is March 5th as opposed to June 7th. If you change the dates around, all that data that I was presenting before was all just consecutive, luckily just worked because it's all just consecutive data. Also is based on date, and using date, if you were actually going to chart on date, really difficult to try to get that as a point, because if you're going to chart from March to June, you have all those days in between. You got to figure out how to put that into a date format. There's a bunch of maths involved. That's what I'm talking about, people, maths. And you don't want to do all that. It's a lot of work. It's really difficult. On top of that, the Y value that you saw in that just happened to work because the Y value is like between 150 and 190 or something, somewhere in there. And that worked because that's the screen size, and it seemed to work. But if your values are more like in the thousands, right? Use one more thing. If it's more like 2000, for example, that would just not work at all. So you have to massage all this data. It takes a lot of work, and it's really complicated. Very bad. So the new way, charts, literally that easy to do a bar chart. It's just that simple. It's one line. The only weird thing is this plottable thing. This X and Y value is a plottable value. If you're not familiar with this kind of semantics, it's not that hard. It's just giving you a label to your point, and you have to wrap it in that value thing. That's it. And boom, it works. And not only does it work, it does it proportionately. It has a background. You can see it gives you numbers, and it also gives you values with no work whatsoever. It's really cool and easy to use, and it's really helpful for apps if you want to visualize data. You can make bar charts, line charts, area charts, rectangle charts. Pie charts, not yet, but I have a feeling that'll come along. So if we have time, I'll do a demo. I think we got a little bit of time for this. Nope. Sorry. Use the old glasses. Here we go. Okay. So the old way, you can see it looks fine, but you can already see that I'm just going to go back here. Yeah, so you see it's a little more complicated. You can't quite fit it the right way. All that kind of stuff is really hard. This is with the simple data, but once the data gets more complex, then boom, it just doesn't work at all. It goes crazy. But with the new way, you can use all those things. Look at how easy it is to make all those different types of charts. And then if it goes complex, boom, it just automatically handles all that. It's really cool. And the, see if I have, yeah, and that's the code to make all those different types of charts. It's just that easy. So I just want to point that out. Really helpful for me because I happen to be looking in for a friend about that certain thing. So there's more resources probably if the slides are handed around. So that's it for charts.
Part two.
Part two. Okay, Regex. So Shai, I think, did this. Hold on a sec. Put my. Shai talked about this already a little bit. Okay, here we go, easy. So Shai talked about this a little bit, probably in more detail than I actually know. But just real quick, the most important thing is how do you pronounce regex? That's got to be discussed because for me, it comes from the word regular, which you wouldn't say regular, right? You'd say regex. But at the same time, you wouldn't say Reggie White or Reggie Jackson or regenerate. So I don't know. Whatever you like. I think it sounds better as regex, but it actually is regex, which is whatever. Yeah, exactly. Same thing. So new in Swift, we have regex. So if you if you've had to deal with this, how many people actually have had to deal with regex? Yeah. Okay. They're a pain. They're super difficult to use. You have to basically learn that. So now with regex, now we have a regex type. You have built-in regex literal syntax recognition, which is pretty cool. So Swift can recognize that, and also this regex builder. Yeah, I hate that reg thing. Okay. Oh, so this is actually cribbed from somebody up at work. So I just wanted to go over this really quick because I thought it was really cool. And I haven't really, well, to be honest, haven't delved that much deep into it. But the thing is, it's a domain-specific language that now you have in Swift. So another thing you got to kind of learn how to do, but it's much easier and much more intuitive. So, for example, it recognizes that literal right there now, just with those backslashes. And I'm assuming that it can actually highlight it specifically the correct way and may even be able to correct it if you have some weird thing. But for those that aren't too familiar with regex, like you got to put in all these codes just the right way and you got to learn them. So now there's these different ways of doing it. You can do it with the literal syntax. You can do it with these runtime constructors. You can do it with the regex builder. And that's the cool thing is this one or more. I just realized everybody online cannot see what I'm pointing to. Cool. You can use this kind of language like one or more, which is easy to understand, one or more digit. It's like, it's just so much more easy to use. So in all these three different cases, at the bottom of the screen, you see it will return 30 from that sentence. So the old way, you'd have to put in that regex, that complicated thing that you'd have to learn how to use or crib from somebody or figure it out. But now you can use this much more sort of obvious language. It's still domain-specific language. You still kind of have to learn how to use it. There's also something called a capture. There's all these different things you can do with it. It just is much easier to use. And it's very powerful because you can mix and match. And you can mix and match formatting that you have already with Swift. You can mix and match a lot of things. Date formatters and stuff like that, you can do that. So it can be very, very powerful to use. If you want to and still understand all that old stuff and you want to use all that time you spent learning your regex stuff, you can still do it. It's fine. But you can also use that new capture, you can use all these different, the new easier to understand language. So that's all I wanted to bring out. In both cases, there's a lot of flexibility and a lot you can do, both with charts. I didn't mention this. There's a lot of things you can do to actually customize those charts. And same here, there's a lot more you can do with it, and just look at the resources. But it's pretty exciting, all you can do. So thanks.
Okay. This presentation is called Just Send It with new Swift concurrency in WWDC. Swift concurrency, like at first I was like, oh, this thing is just syntactic sugar over closures. And like that, don't get me wrong, like that's actually really cool, but there's actually a lot more to it. And I'll go back because I don't want to go on to that next slide. It's way more powerful than what Apple has let on. And I'll talk about that. But it's a big concept to actually wrap your head around, even if you're familiar with closures. So instead of closures, you have this thing called a task. So, well, what is a task? A task performs a specific job from start to finish, kind of like, you know, you're doing a dispatch on a global and maybe to the main, it's going down the line, just like that. They're linear and sequential. They're asynchronous, kind of just like a closure. And they're self-contained. Like everything that you need is captured in the body of that closure. And like, here's an example of one. And just, you know, some of you may know this, some of you may not. But the way this works is the first line has to finish asynchronously before going to the second line. So the fish has to be caught before you can cook the fish. And then you have to wait to cook to then eat the dinner. And of course, with closures, this would be 3 nested levels of closures, and it would be hard to reason about. So already, like this await syntax is great and keeps things like really easy to follow. And you know, in the Apple talk this year, they want you to think of a task like a sailboat. It has everything it needs, and it's floating around on what they're calling the sea of concurrency. It's like your CPU, it's like everything running on your app at one time, but the sea is chaotic. Like there's tons of boats, everything's happening. And, you know, something like this is kind of hard to reason about. Like we don't cook fish or eat whatever in our apps. Let's like look at maybe a more realistic example. So one thing I'm excited to migrate to async await is an image downloader that I just made for fun, but I mean, everyone uses all the big ones anyway, but it's kind of cool. So let's say you have these multiple sequential steps that you want to use to display an image. So one sailboat would be downloading the image. That's an asynchronous task. And like probably in that task, you're handling errors or whatever you're doing. Then maybe you want to downscale that image. And then maybe after that, you want to make the image black and white because you want to be artsy about it. But, you know, how do you get between these boats? Like, how do you send that information along? Tasks are independent and isolated. We know this. So how do we do it? Okay, introducing Sendable. So it's actually already out. There's a protocol called Sendable. And what Sendable says to the compiler is this object can be sent between these boundaries without thread safety issues. Structs are obviously sendable by default because they're copied on write. And there's a, like, if you look back at what Swift has been doing as a language, they introduced like structs years ago. They're playing the long game with us. They're like, structs are the future of things because they're so safe. And you should be using them anytime you don't have to use a class. Classes then, by contrast, are not sendable. They can be accessed in 2 places at once. And I think often in our code, we don't even realize when we have race conditions and things going wrong. And then also I want to mention that closures themselves are not explicitly sendable. You could capture a class in a closure. And you can actually, there's syntax to mark a closure at sendable, kind of right before you do the weak self, you can put an at sendable to make it clear that everything in the closure needs to be sendable and checked by the compiler. So going back to this image example, are UI images sendable? Like, no, right? They're data, they're not structs. Wrong. They've introduced this thing called @unchecked. And that's a way of tricking the compiler and saying, you know what, actually, like, I can be sendable because whoever wrote me under the hood has done sophisticated things to make me thread safe. This is an example from the Apple talk. They have an NS lock that's, monitoring thread safe read and write from the storage. And even though it's a class, because they put on check Sendable, they're like, you can do this. And Apple, of course, in the talk is like, don't do this, Like, it's there as a last resort. And I think what you'll see in these next couple slides is there's a lot of ways to leverage what they're calling actors and these other things to not have to use classes at all. Okay, so how do we get data from one task to another? Now that we have this protocol that says how you can send something safely, and what about things that are mutable state? Like you're flipping things on and off, like your app responds to state, you need to be able to manage that somehow. So that's where actors come in. So, well, what's an actor? Actors provide a way to isolate state that can be accessed from different tasks, but in a coordinated manner that eliminates data races. In other words, they're kind of like a serial queue. If multiple tasks need to run code on an actor, they get queued serially. And they call them islands because they're kind of like where everyone meets up. All the boats meet up at the island. Maybe you drop things off at the island. And what you want to remember when you're writing async await code is that anytime you see await, it could be a moment that your task suspends. And anything after that may not happen for a minute, 5 minutes, 10 minutes. Like you just don't know. And it's a way of reasoning about your code. Like, do I have everything I need to complete this job in this task? Or is there a code smell? Is there something going wrong? So interestingly, actors are reference types. They hold state and they're mutating a lot. But unlike classes, they're super smart at the compiler level. They isolate all their properties in code to prevent this concurrent access. It's kind of like they have NS lock built into it. It's super nice. And you will get a compiler error if you try to access them improperly. And they're implicitly sendable, which I think is interesting. So they're classes, but you can wrap a task around them. So if you need multiple tasks to like reference the actor, you can do that because the actor is serial. It's thread safe because it only does one thing at a time and prevents multiple access at the same time, which is a data race. So this was an interesting point. Because like back in the day with this image downloader, I just did .sync if I wanted something to run in a linear order. So what's different? Well, actors are smarter. Like this is going back to what I'm saying about like under the hood, they're doing things to be even better than what they're replacing. So actors execute the highest priority work first, not in a FIFO, first in, first out, like a serial queue would. And this is important because there's performance optimizations. So an actor is so smart that it can know like certain things are needed by the UI. It'll process multiple UI tasks before like a background task like logging, and I'll show you that in a second. And that's what I'm saying when they say they intelligently prioritize work. And so for the demo, it's going to be really quick, but I will share my Xcode. And I'll be honest, this is new to me, but I've been just rolling up my sleeves and trying to like get familiar with like real concepts, because only doing that if I've been like, well, wait a second, like how would I solve a certain thing? So this is very rudimentary, it doesn't work, but it's an image downloader, that's an actor. It's our state, and maybe it would have a cache of images, and maybe it would have a logger. Maybe it's like the glue for a bunch of asynchronous tasks. So let's say you want to download an image. Of course, it's marked with async and throws. And so maybe this first await, you're downloading the image, which is asynchronous. And then here would be some pseudocode for like, maybe you have this task that's doing the downscaling, and maybe you have this task that does the black and white. And then maybe at the end, you would want to log a message like it was downloaded. But what's super cool is like this task detached is a way of telling the actor, hey, actor, like I know more than you about what thread, or what priority rather, not thread, what priority this should be run on. So a log message is not important, it's background. So remember, this whole statement is asynchronous. Let's say you download 2 images immediately, like you're loading a collection view or a lazy grid, and 2 images come in. I believe it's possible, based on what Apple's telling us, that image 1 and image 2 may run all this code before these 2 logs execute. Like, this order is not necessarily guaranteed because I've wrapped this in detached. What is guaranteed is that this will run in a linear order until finally returning the image for one image. But what's great is that they're doing a ton under the hood to make it even faster. And I'll link to at the end, but there's a talk from last year where they go under the hood about how this works. Back in the day, you would switch between thread to thread to thread, even just on a background queue. If you were calling dispatch queue global, async await gets rid of all of that. Your actor will execute on one thread, and they're using function calls to switch between tasks, which saves, what they're claiming is a lot of CPU time because it's expensive just to switch background threads. So async await is not just a pretty wrapper, it does a lot for you. And I had some other examples of like things not to do. So this is actually just more of a comment. So let's say you have like UI kit code. This method is not asynchronous. In fact, like if I move this await out here, the viewDid load will start to complain that this function is not, async is not supported, like you can't do that. So if you're starting to use it in your own code, be mindful that you have to do it within a task, or maybe you have an actor on your view controller. And I'm still exploring what the best patterns are to do that. You can return an instance to a task. That task you can cancel. And async await, again, being super smart, can propagate that cancel message down to any subtask. And they're smart enough to like know when to cancel or know when to stop. So another very powerful thing. And then another thing that they talk about in the WWDC talk this year is don't abuse an actor. So I have this actor and, you know, maybe you forgot to mark something private. So you have this serial, seemingly thread-safe dictionary. But if you do something like this, where you reach into an actor and try to pull out an image, do something and then set it back, you're going to start getting warnings like this because it's like, yo, you did not do this within the island. You did not do this within the thread-safe context. And that's what's important to remember, is that these actors are going to only guarantee their thread safetiness if you're doing things within them. And then, yes, you can use Sendable or tasks to send things between actors or between these isolation points. But I think it's just really important to know that that's how that works. One final thing I'll point out is, let's say you create a task just like this. There's no .resume. It will just start executing. Of course, it will get scheduled and the CPU will decide. But if you want to access it later, you can do task.value to get what the value is. So like if you're running an async task, even if it finishes ahead of time, you could say like let image equals async, what is it? Await task.value. And it's going to complain because it's still in viewDid load. But this is how you would do that. And that's like a way of maybe reaching in and getting something when you do need it. So I will stop sharing that. I think I might have just one or two more slides. Here we go. OK, so how do you roll it out in your own code? So there's a new compiler flag. It has 3 levels. Minimal, which is, OK, the compiler is only going to diagnose places that already you've marked sendable, or it's a class, or excuse me, a struct or something that it conforms to sendable, a closure that conforms to sendable. The next is targeted, which extends that reach to any async await code in your app, even if you've not marked it sendable, because async await is the basis of sendable. And then there's complete, which is honestly kind of what I think I'd like want to just try first and see how much of my code is not thread safe. But it looks for everywhere data races could occur, including a dispatch queue.global. Maybe you passed in a reference type into a dispatch and like accessing it in multiple places. The compiler will check that. And so this is what that looks like. And then they've also added ways, just like the at unchecked that I showed you earlier. Let's say you import a framework like that doesn't yet import or like do this at Sendable. You can mark it with at pre-concurrency, which means, hey, they haven't done it yet, compiler ignore it for now. It is smart enough though, it caches that result. So if that framework one day then raises its strict concurrency checking, it'll recheck your code that uses it and make sure your code is safe. So it's safe to put this there and not worry that you're gonna forget about it later. And then here are the list of those talks. There are so many. But the most important ones, like obviously the top one, which is where a lot of this talk was based on, and this one with the emoji is super, super technical, but I think gave me the most respect of like what async await really is and the power of it and how much better it can be for your code. So thanks.
All right, so yeah, I wanted to talk to you about today about the generics in Swift and the improvements that they made for 5.7. So, all right, so first of all, I wanted just to do a very, very quick introduction if people don't really use generics or have never really used generics. So pretty much it allows you to, if you have, for example, multiple methods that does the same thing, to just refactor them in one. So you just specify a type and you just get one method afterwards that which the compiler is just gonna replace the type at compile time, and then you just only have one method. Another example is let's say you have, for example, a method that takes an array of int. In this case, for example, you could have do something, takes an array, but sometimes you also maybe want to give a set of integer. So in that case, you would have to actually cast it. So if you use generics instead, you would have this syntax right there, which is very verbose, that would allow you to actually make the same code, pretty much the same call point here for the generics. And let's get going. So imagine you have an item protocol that just has a name, define a book, a key, and then you have a user that has a list of items. If you make that item hashable, you will notice, I'm sure most of you have seen that error, that the compiler is going to complain with that error. Can only be used as a generic constraint. It has self-associated type. And in the past, you would have to resort to something that is called type erasure, where basically you have some sort of a box where you would put your actual item protocol implementation and use that as a basically placeholder for your item. And this way, the Swift compiler will not complain anymore. So Swift 5.7 does a lot of improvements for this. Allows you to write generic code much more easily. It provides a new keywords, so some and any, and also provide the a new mechanism called primary types for protocols. So let's get over all of them. So first, some. It allows to indicate that we expect an instance of a type. So given the example, for example, my item some item equal a book. At the compile time, the compiler is basically replace some item by book, and it means that if you try to assign it something that's not a book, it will complain and say you're not allowed to do that. Then you have primary types. So protocols may have more and more primary types. They are defined in between angle brackets when defining a protocol. So for example, for collection, with Swift 5.7, you can specify it does specify now element primary type. And it allows you to do so. If we come back to the definition we used to have for this verbose collection method, basically replace it with this code, which is much more natural to write in Swift, some collection of int. And it will allow you to use any kind of array set or anything that is a collection of int. Then let's talk about any. So it is basically a language enable type erasure. So it is defined by the Swift internally, but as an existential type. It can be thought of as a box that contains the type. So in the same way in the past you had any item, or if you worked with Swift, you also maybe worked with like any hashable, any collection. Those allow to basically so it's just a container in a way, and allows you to have a book, but also assign it to a key or any kind of item you would have. So it means that in Swift 5.7, the error that used to happen all the time, if you work with hashable or quotable, it is basically gone. So now you can basically replace that with any, and the code will pretty much work. It means that you can make now any of like your old protocols, equatable, quotable, or anything else without relying on complex user-written like type erase types, which you might have done in the past. One of the caveats, though, on this approach is that when you do any type, it doesn't actually conform to the type. It's only the underlying type that conform to the type. So, for example, any equatable doesn't actually conform to equatable, but the Swift compiler will actually, in most cases, open the underlying type whenever you want to use it that way, and it will basically be invisible to you. There might be cases in the future where this might result in error, but the behavior right now is, in most cases, it will basically just open it implicitly for you. So to summarize, Swift generics were made much easier to use in Swift 5.7. No more of this error that was plaguing us in the past. Easier to write methods, and a more concise way to write methods through the sum keyword, and type erasure being part of the language through the any keyword. You might want to watch the WWDC sessions, embrace Swift generics, and design protocol interfaces in Swift. And if you want to dig more into the why it's like how when the box opens, you could look at the actual evolution proposal from Swift on their GitHub, which goes into much more detail. And yeah, that's me. Thank you, guys.
These are some great talks. So there is nothing like being the guy between you and beer and socializing after a pandemic. So I'm going to keep it short and sweet and talk to you a little bit about the latest in complications and widgets. So my name's Dan. That's my Twitter. I have my little side company that I run for app building, and I also work at Capital One, based down in Virginia. Let's talk, just get a quick background. We have complications. For those of you who don't have an Apple Watch or are new to the space, complications are the little doodads on your watch that show information. So there are the little circles there, the little square areas, the little curvy areas at the side of that left one. Those are all called complications. And they are provided by Apple, but also you can create them yourself for your app. And just give you a quick history of it. They were first introduced, this should be trivia time, but they were first introduced in watchOS 2 in ClockKit that made it so you could build with complications. Then watchOS 5, they introduced rich complications with more colorful and graphical content. watchOS 7 brought Swift UI complications, and multiple complications were introduced. And now in watchOS 9 is the latest with complications, which is they've been reimagined and remade with WidgetKit, which is what the new framework that Apple introduced, I guess 2 years ago now, to build widgets. That you now build complications with WidgetKit, embracing Swift UI and bringing these glanceable complication experience to iOS in the form of widgets. And I promised you I would be fast. I will also be colorful, because Apple loves their colorful things, and between you and me, I think they lost a little bit with this, but we'll proceed and discuss. But first, before we get into the colors, which is like a big chunk of the presentation, we'll talk about the new types. So basically what they did is they took the complications and moved them into these new lock screen widgets you see on the right there on your phone, that are in iOS 16. So they have different families now. And if you're familiar with widgets, you have small, medium, large, and extra large widgets for the phone and iPad. And now they've introduced accessory circular, which is the circular, the 72 one, and the ones next to that. Accessory corner, which is the one that only on the watch that you saw in this previous screen here. Accessory rectangular, which is in the middle of the watch there, the WWDC 22 keynote, and its partner there on the lock screen. And then accessory inline, which is kind of cool, actually. It's actually the line above the time on the watch or on the phone there, the Monday the 6th Cupertino. That's actually customizable. So you'll be able to put maybe some information from your app there. So I mentioned color. So with these new complications, they have 3 different color types for them that are mandatory. They come with all complications and all lock screen widgets. On the left there, you see the traditional full color, which just shows the colors as they were put in by you, the developer. Then you have accented, which is the middle there, which actually turns your complication or your widget into a 2-tone. It takes 2 different colors and shows it. And then on the right, you have vibrant, which takes your complication and desaturates the color. Also, what I like to call the "where did my widget go" color. In fact, I think Apple's working on it. They actually, in the Slack chats during WWDC, and the WidgetKit team was talking about how, yeah, we got it. Beta 2 will make those so you can see them better. So they also realize, oh, we got to make sure you can see these as well. But the accented, it's super interesting, I think, for your designers. Interesting might be the wrong word, potentially frustrating, because basically the designer cannot define exactly how it's going to look because it's so customizable by the user. So this is the accented mode, right? The 2-tone mode. And these are all variations of the 2-tone mode, some that even reverse the tone colors. And so really there will be a lot of testing of like different, how does it look when it's reversed colors or a full color background, like that third one. So those are all the different colors that a user can set that your complication or widget will need to be able to remain visible when those are used. So just a really quick, before I wrap up, I'm going to show you what all this looks like. So here we are. This is Xcode 14, and you see on the left here, you have your view builder for your, this is WidgetKit stuff, right? But now they've added new families: accessory circular, accessory rectangular, accessory inline, and those go right in with your system small and other widget sizes. You actually, at the bottom here, you know, you say if watchOS, it supports these 3, otherwise you support all of them, right? So that's where that gets in here. And then I think they're really starting to, if they can get them working reliably, the previews, they're really becoming very helpful in development. Like this new one you see at the top here, you have circular, a rectangular widget. You can see the view, you know, isolated on its own. You can see your inline. You can see your widget. You can see all 3 different sizes. They haven't actually built a large one for this demo app. and the various colors. Right now, it's just dark mode and light mode. I imagine they'll put in the other modes as well at some point, or maybe it's there and I just didn't find it yet. But that's what that looks like. And so just to wrap up, where did that go? There it is. If you want to learn more about this, this is the WWDC talk that this talk I just gave is based on, and there's the link to the sample app. I'm sure we'll be sending out these presentations to you afterwards, but you can take a look at it and play around with those. And that's it. Thank you so much. Enjoy the rest of your evening.